Hi everyone. My project title is an efficient packet classification in network security system. Here we go with the execution process. What happens is we'll be using an ID SQL for the backend, then Eclipse for the front end Java coding. Eclipse is opening up, just takes up some time. Wait. We'll be having SOC folders. That's the list of programs that have been coded for this project. The controller contains the main code for the Java startup. That means initialization of the server. So if the controller is not, the server is not initialized, then the further procedures won't be taking up. The controller is initialized successfully. Then we going off the register login frame. In this process, we'll be creating up a network made up of nodes interconnected with another nodes. If this, since it's the first initial node, we'll be connecting it. We'll be just giving and creating it. Then we log in to get an frame contains of both a sender frame and the receiver frame. Still got to create some more frames. So it will be a slice cup of network. We'll be creating name it B, then registering it. The intermediate node will be A, and the distance will be as given as 6. Connection created. Finish. Logging up for the second thing. Pick up welcome. Creating another node. I think 3 more nodes is enough for this execution videos. We can create you can even create a very large networks using these. It takes some time, so I'm just brushing it up like this. Just 3 nodes created in the networks. I'll be stating what is the process that happens after this. We are in the node C, and we are browsing for the folders. We'll be selecting the destination. Consider the destination as A. There will be a list of possible paths given if there is an very large networks. As you can see, LBS studies these in some networks graph theory subjects. Possible paths are will be discovered here. We'll be choosing up an optimum path. It is listed from low to high in this possible path table. This is the number of packages that get classified. The package size is purely depends on the whole content, whole data file name. Every package has the same size. The last package just varies with another thing. Since the whole size of the packet, it's not common. Be sending the packet. After sending the packet, the data has been traversed to B. Will be going to the mainframe. This notification what suggests is the packet is being classified, and in the packet there will be an 5000. For just example, I'm giving up 5000 rules. These 5000 rules are divided into sub rules, and they are being used up an approach called merging partition decision tree. What happens is in the merging partition decision tree, there'll be a decision. Using those decision, there'll be a decision in the head node. Using those decision, if it goes good, it will come to the left node. If it satisfies the condition accordingly, there'll be on left or right. Using these arrangements with the rules that's been divided into sub rules, this get allocated accordingly, and this trees are merged to form a single tree, and these trees are stored in a table. The table is what the table contains is the table is present in the intermediate node. The nodes that is present in the intermediate. Every intermediate node performs this operation. The merging partition decision trees is stored in the table, and the table has an the table as an memory alignment. There'll be an bar line, consider an threshold level like catchy line size and memory alignment. So this makes the table size doesn't grows higher even if the rule set size grows higher. Make clear? Table size doesn't grows higher even if the rule set size goes higher. Then we'll be going to the stage of merging. So if there is more number of rule sets and this more number of data are coming up, we'll be merging those trees together. uh, how is the similar key values are grouped up together and they are saved in the table, and they are saved in the single tables. Then last approach is the searching through integrated table. The table, the node present before the last node is here b. This is notified because this notifies this the backend process are complete, and the data in this the data is stored in the table. This simplifies that. That's the meaning. Since what why this is all this procedure happens in the backend, since we are giving up this, so there is nothing in the front. The frame will be goes just going to the last user A frame. User A is a receiver frame. The data has been passed to the range. It has not been received yet. Let's wait for some time. Have the data being received in the receiver frame? That's it.